Hello! In today's video, we'll be discussing Newton's second law. Newton's second law is the law that describes to us mathematically the relationship between an object's mass, net force, and its acceleration. Newton's second law states that an object's acceleration is based on the net force applied to the object and the object's mass. Specifically, it tells us that acceleration is directly proportional to the force applied to the object, but indirectly proportional to the object's mass. Newton's second law can also be stated in an equation form. This equation can also be used to calculate any of the three variables included in it. To state Newton's second law in equation form, we would say that the sum of the forces is equal to mass times acceleration, or in short, F equals ma. If you're not familiar with it from math class, that symbol there is a sigma. That means sum. We know that net force is a sum. So when we say sigma F, we're referring to the net force. Lowercase m is the mass of the object. Important to realize that that is always in kilograms. So your mass must be in kilograms for you to solve for the correct answer. Finally, we see an A, which is our acceleration in the units of meters per second squared. This tells us that the sum of the forces acting on an object, we can also call that the net force, is equal to the mass of that object times its acceleration. You can see over here, again, that force is equal to mass times acceleration. Now let's break this down and talk about how each one of these variables, mass and force, affects an object's acceleration. So you may have remembered from the beginning of the video, I mentioned that acceleration is indirectly proportional to mass. This means that objects with greater mass or more massive objects will actually require more force in order to undergo the same amount of acceleration. We could say that the more mass, the less acceleration that an object will experience. We can think about trying to push an 18-wheeler to try to get it to accelerate. It would require a very, very, very high amount of force that is based on that object's inertia. On the other hand, lesser mass objects, or objects with less mass, require less force to undergo the same amount of acceleration, or will accelerate more with a lower amount of force applied. This also is because objects with lesser mass have less inertia. So an object with a much smaller mass will require much less force to accelerate, or with the same force applied, will accelerate much more. Now let's take a look at the effect or the relationship between force and acceleration. You may also remember that I mentioned that unlike mass, force and acceleration are directly proportional. This means that with a greater net force applied, the greater an object's acceleration would be. You can think about any time you apply a force to anything, maybe kicking a soccer ball, throwing a baseball. If I apply more force, that will lead to more acceleration. On the other hand, if I apply a lesser net force, or if the object is experiencing a lower net force, this object will experience less acceleration, or the resulting acceleration from that net force will be lower. So with a smaller force, a lower net force will lead to lesser acceleration. Now let's break this down even further and look at all of the potential relationships between force, mass, and the resulting acceleration. So first, let's think about two objects that have the same mass, equal mass. An object that experiences a greater net force will experience more acceleration than an object with the same mass that has a lesser or lower force applied. On the other hand, Let's think of two objects with different masses that are experiencing the same force. The object with the greater mass will experience less acceleration. Remember, that has more inertia, hence will accelerate less. Whereas the object with lesser mass will experience more acceleration when subjected to that same net force. Now let's go ahead and look at a couple examples of using the mathematical form of Newton's second law to calculate acceleration. So this first question asks us, what is the acceleration of a 50 kilogram object when a 500 Newton force shown below is applied? So first, like we should with any problem, let's go ahead and identify our knowns and what we're being asked for. So we know we're being asked to calculate acceleration, and we are given the mass of the object as well as the net force on the object. So let's take a moment to go ahead and write this out. So A is what we don't know, it's what we're solving for. We know that the net force here, you can see it's the only force acting, so we'll assume that is the net force, 500 newtons to the right. And we also know that the mass of the object is 50 kilograms. Now we're ready to solve. So we know that Newton's second law tells us that the sum of the forces is equal to mass times acceleration, F equals ma. We know that we're also being asked for acceleration, so I will need to isolate acceleration in this equation. In order to do that, all I need to do is divide by m. That will cancel out, and I'll be left with A is equal to the sum of the forces over the mass. Now we're ready to simply plug in and solve. So again, we know that my net force here is 500 newtons. We also know that the mass of this object is 50 kilograms. We know that 500 divided by 50, do this an easier way, cancel out a 0. We know that 50 divided by 5 is 10, a little mental math. We know that the units for acceleration are meters per second squared. So the acceleration that this object would experience is 10 meters per second squared. Now we'll look at a second example. This asks us, what is the acceleration of the 15 kilogram box that has a 500 Newton force applied to the right? Now, I want you to compare this to the situation that we just looked at. We can see that the net force is still 500 newtons to the right. However, in this case, we've gone from a 50 kilogram box to a 15 kilogram box. So I encourage you to take a moment to pause the video and make a prediction about what the final outcome for this acceleration is going to be compared to the first box. We'll go ahead and identify our knowns and what we're being asked for. Just like in the previous example, we know that our A is what we're solving for, so it is currently an unknown. We know that the net force is equal to the 500 newtons to the right, and in this case, the mass is 15 kilograms. Of course, we know that we're going to use the same equation to solve. Since we did just algebraically manipulate the equation, we'll just go ahead and plug right into that, knowing that acceleration is equal to the sum of the forces divided by the mass. In this case, my net force is the same, 500 newtons, and my mass is 15 kilograms. We'll go ahead and plug that into the calculator and come up with an answer of 33.33, repeating, we'll round it to 1 decimal point, meters per second squared. So what did you predict when you paused the video of what the resulting acceleration would be of the 15 kilogram box compared to the 50 kilogram box? Hopefully you were able to say that because this box is experiencing the same net force, but has a lesser mass, we can see a much higher resulting acceleration, completely supporting what we know of Newton's second law.